Hi there, boys and girls, and welcome back to Conquering Math, where it all adds up. Today we will be learning about perfect squares. Let's dive on in. By the end of today's lesson, you will be able to determine whether a given number is a perfect square and use perfect squares to solve real-world problems. The Common Core State Standard today is 6EE1. We should start with the definition of a perfect square. A perfect square is the square of a whole number. For example, 7 squared equals 49, so 49 is a perfect square. If you drew a square, you could see how this works. We have 3 squares going across and 3 squares going down. So 3 units times 3 units is 9 square units. 9 is a perfect square. For example number 1, we will start by creating a list of perfect squares. It can be useful to create this list because then we can refer back to it for other problems. It might be helpful for you to practice by doing this several times. Let's start easy. 1 squared is 1 times 1, or 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. And 12 squared is 144. You can keep going on as long as you want, but typically this will be enough to help us out in other problems. Example number 2. Determine if the number is a perfect square. The number 25. Now we could just refer back to our list, but we want to practice. So let's try this. We'll keep writing down perfect squares until we either find the number that matches, or we find that we've passed the number that we're looking for. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. We still haven't reached 25, so we have to keep going. 4 times 4 is 16. Keep going. 5 times 5 is 25. So 25 is a perfect square because 5 times 5, or 5 squared, equals 25. Let's look at another one. Determine if the number is a perfect square. 30. 1 times 1 equals 1. 2 times 2 equals 4. 3 times 3 equals 9. 4 times 4 equals 16. 5 times 5 equals 25. 6 times 6 equals 36. You'll notice that 30 fell in between the perfect squares 25 and 36. If we keep going, we're just going to get larger and larger numbers. So we know that 30 is not a perfect square because there is no whole number squared that equals 30. Example number 3. Maya wants to plant grass around the outside of her vegetable garden. The garden is a 4-foot by 4-foot square. Maya is planning to plant 1 foot of grass around each side of the garden. What is the area of grass that Maya will plant? The first thing that we need to do is to find the dimensions of the whole shape. If we take the side length of the smaller square and add 1 foot to each side, we can find the side lengths of the larger square. So we have 4 feet plus 1 foot plus 1 foot equals 6 feet. Remember that there's 1 foot on each side of the small square, so you have to add it twice. So each side of the large square is 6 feet. Now we can find the total area of the grass in the garden and then subtract the area of the garden. This will leave us with just the area of the grass. Remember that for a square, area equals the side length squared. So the total area is 6 squared, which is 36 square feet, which we write as feet with the exponent 2 next to it. The area of the garden is 4 squared, or 16 square feet. Now to find the area of the grass, we'll subtract the area of the garden from the total area. This leaves us with 20 square feet. So the grass around Maya's garden will have an area of 20 square feet. Today you learned how to determine whether a given number is a perfect square and to use perfect squares to solve real-world problems. The Common Core State Standard today was 6EE1. Now that you are familiar with these techniques, complete the independent practice problems in your guided notes packet. Then watch the independent practice solutions video to check your work. Thanks for watching this episode of Conquering Math, where it all adds up. I'll see you next time.